To understand the nature of the wandering child of the sky, the wind, try this simple experiment. Take a lit candle or a feather and slightly crack open your door. Ensure the inside is warm and the outside is cold. Hold the candle flame or the feather near the top edge of the door opening. You'll observe the flame bending outward, pushed by the wind blowing from inside to outside, and the feather drifting outward. Now move them near the bottom edge of the door. This time, the wind blows inward, bending the flame inward and pulling the feather inside. If your hand is sensitive enough, you might feel warm air near the top and cold air near the bottom. But what causes this breeze and the temperature difference? The warm air inside the house, which is lighter due to expansion, rises, while the heavier cold air from outside moves in. When the door is opened, the warm air escapes through the top and the cold air enters through the bottom. Let's scale this concept up to see how the Earth warms and cools. The equatorial region is much warmer than other areas, while the poles are extremely cold. Warm air over the equator continuously rises, and cold air from the poles rushes in to fill the void. This movement causes winds to flow from the north to the south in the northern hemisphere. However, because the Earth rotates on its axis, the winds are deflected. To an observer on the ground, this deflection makes the winds appear to flow from the northeast to the southwest. Near the equator, in the regions where trade winds blow, this effect becomes even more pronounced. In temperate zones, the situation is slightly more complex. Various factors cause winds to flow differently in specific areas. However, the primary mechanism remains the same. Cold air moves in to replace rising warm air. In the Mediterranean region, for example, winds blowing from land toward the sea fill the gaps left by the rising warm air along the coast. The temperature differences between land and sea also create winds. In summer, land heats up faster and more intensely than vast bodies of water, which remain relatively cool despite minor temperature changes. As a result, cool breezes often blow from the sea toward the land, bringing rain. Winds from the west are called gunbadasu, while those from the southwest are called keshishlemi. In winter, however, the roles reverse. Seas remain warmer, while the land is covered with snow and ice, causing winds to flow from land to sea. Here we focus on the interplay of temperature differences between large land masses and water bodies. As the Earth rotates, it forces air masses to spin around centers of high and low pressure, shifting these centers as well. This dynamic makes forecasting the weather a challenging task for meteorologists. The speed of the wind depends on how much hot or cold air is present to restore balance in the atmosphere. On the hottest summer days, when vast land masses bake under the blazing sun, cool winds may arrive faster than expected, filling the void and causing sudden changes. These abrupt shifts can create storms known as tornadoes. In tropical regions, where warm air is exceptionally light, it rises into the sky and begins to spin. If this rotation becomes a vortex, it can form a cyclone capable of pulling up seawater, houses, trees, animals, and even people. Cyclones, resembling a funnel with a wide mouth pointing downward, can destroy everything in their path. Yes, wind has its destructive side, yet it also serves us in so many ways. In the end, we should feel fortunate to have this boundless traveler of the skies, the wind that crosses mountains, valleys, and borders to bring life and change wherever it goes.